Okay, so we've got GMA, we've gone grams to moles, moles to grams. Now we're going to do moles to atoms and atoms to moles. To start that idea off, we have to think about numeric relationships between atoms and moles. So if we're doing moles to grams, we know that the conversion factor we're going to use, here, I'll get rid of that for right now. If we're going from grams to moles or moles to grams, there's a relationship between those two things, right? What's the relationship? Two words. Both start with M. Molar mass. So the conversion factors that we've been using have all been things like, you know, moles and some number of grams, or grams and moles, because we're converting between moles and grams. Okay, good. Because that's a relationship we know and we can find for any single element, any element in the entire universe. Well, now, if we're going to go from atoms to moles, or moles to atoms, we have to have a relationship between those two things. We do, and that relationship is Avogadro's number. So, Avogadro's number, this number, is how many atoms are in any mole of anything. That's how many pieces are in any mole of anything. So now, instead of using these conversion factors, now we're going to start using moles over atoms, or atoms over moles, because we're converting back and forth between atoms and moles and atoms. So, we said Avogadro's number is the relationship. If you would like to get Avogadro's number tattooed on the inside of your arm, I'll let you take all your tests wearing short sleeves. You're going to use it that much for a while. When we use these conversion factors, how many atoms are in one mole? All together, like a bunch of nice little chem zombies. 6.022 times 10 to the 23rd. How many atoms are in one mole? 6.022 times 10 to the 23rd. So, we're always talking about 1 mole, and we're always talking about 6.022 times 10 to the 23rd atoms. When we're using these conversion factors, those are the numbers we're going to use. If we're dealing with carbon, how many atoms per mole? 0.022 times 10 to the 23rd. If we're dealing with sodium, how many atoms per mole? 0.022 times 10 to the 23rd. If we're dealing with aluminum, how many atoms per mole? 6.022 times 10 to the 23rd. Okay, we get it, Moser. Thank you. So we're asked to find out how many moles of calcium are in 2.01 times 10 to the 15th atoms of calcium. What's our given? Number of atoms of calcium. So we take 2.01 times 10 to the 15th atoms of calcium. What units and what chemical are going to go down in the next box to cancel? Atoms of calcium. What units and what chemical are going to go up top? Moles of calcium. Okay, what numbers go there? What number goes next to moles? 1. Always 1. Never anything else. 1, and it shall be 1, and it shall not be 0, and it shall not be 2, and it shall not be some crazy thing like 131.7. 1. 1. What number goes next to the word atoms? 6.0222 times 10 to the... Yeah, exactly. Avogadro's number, 6.022 times 10 to the 23rd. And no other number ever goes next to atoms. Don't ever put 40.08. Don't ever put 197.3. 6.022 times 10 to the 23rd. Okay, our setup is complete. We're ready to solve. So we take 2.01 divided by 6.022, that whole mess, times 15 minus 23. So now it's just math. Okay, we have a raw answer, 0.333776154 times 10 to the negative 8th. Is that correct? What do we have to do? We have to fix two things. We have to move the decimal, we have to sig fig it. So it's a good raw answer, but we got to sig fig it. So if we're going to fix the decimal, let's see, and pretty soon even my little pea brain gets that this is going to be to the negative 9th, right? How many sig figs can we have? Hold up fingers. 3. Because we're getting our sig figs from here. Our conversion factors don't count for or against us. So our sig figs are coming from our given. So we can have 3 sig figs. We're going to keep this and round based on that. What's our final answer here? Oh, it's written down. Duh. 3.34 times 10 to the negative 9th moles of calcium. Not so bad. Let's do one more of these together. Then we'll turn it on its head, and then we'll get into the really exciting stuff. We'll dive off the cliff. Okay, so we've got our setup. Now it's just math. I forgot to hit the unpause button. So, do the math. Okay, do you have the same raw answer as me? What do we have to do to fix this up? Move the decimal and fix the sig figs. So, to the 4th. So this would be to the 3rd, right? It's going to be 6.9 something to the 3rd. How many sig figs can we have? 3. So we're going to keep this number and round it based on that one. So we have 6.9 what? 7 times 10 to the 3rd moles of gold. It's a lot of gold. It's a whole lot of gold. That would be our final answer. So, these are atoms to moles. Now let's flip it. Let's go backwards. We have a given number of moles of copper, and we want to know, oh, I guess I started to set it up already. We want to know how many atoms this is. Okay, so we've got our given in the first box. What goes down here, units and chemical, to cancel? Kayla, I know you weren't here yesterday, but are you catching on? You want to try it? Be careful. It has to cancel. Which one goes down here? Units and chemical to cancel. You can call for an assist. And you weren't here yesterday, so you didn't get the pattern. No. You want to try it, Madison? Oh, you did. No, you gave me the date. Okay. Yeah. It's going to be moles of copper, just because it has to cancel. Okay, so moles of copper. What units in chemical is going to go up top to end up in Ashlyn? Atoms of copper. Okay, now, Ella, I'm going to give you the hard one. Give me the numbers for both top and bottom. Which goes where? What do we use? Yes. And the bottom is 1. Okay. I say that's the hard one, and this morning I caught a couple people on it. It's really easy when you're only having to think about one. Suddenly, when you have to fill in all the boxes, which is the experience you have when suddenly it's you and your homework or your quiz, it's easy to flip those around and screw them up. So just remember, there will always, 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 always be a 1 with moles if it's a conversion factor. Always. Nothing else goes next to moles. Just 1. Okay, now it's just math. Okay, we've got a raw answer, and this is, of course, atoms of copper. What do we have to do?
Scientific notation.
Yeah. Fix the scientific notation and put it in correct sig figs. So that would be to the 24th. 3.6. How many sig figs can we have here? 3. So we're going to keep this 7 and round it based on the 3. So 3.67 times 10 to the 23rd atoms of copper. What did I? Yeah, thank you. I'm like, no, what did I do wrong? It's right. No, it's not. Thank you. You got to keep your eye on me every minute. I screw up all the time. Okay. 3.67 times 10 to the 24th atoms of copper. Pretty easy, right? So that was moles to atoms. So we've now done grams to moles, moles to grams, atoms to moles, moles to atoms. These are all one-step conversions. When you guys were back in that tan cupboard, did any of you see the special mole balance? You didn't see the mole balance? So the one that if we take a chunk of copper, we stick it on the mole balance and it automatically tells us how many moles that is. You didn't see that? There's a reason you didn't see that. No such thing. So, in some of these problems, as we're learning the steps, I tell you, oh, you've got 4.2 moles of aluminum. Well, nobody's ever going to tell you that ever anywhere, because you only know how many moles something is based on its mass. So these are great problems in terms of learning the steps and learning a one-step conversion, but really, we typically do conversions with more steps than that. So if we look at GMA, the reason we use this is as a visual reminder that if we want to go from grams to atoms or atoms to grams, do you think we can go straight from grams to atoms? We have to go through moles. Every single conversion that we do from atoms to grams has to go through moles. Every conversion we do from grams to atoms has to go through moles. So these will be two-step conversions. Let's start with, okay, we're asked what's the mass in grams of 2.01 times 10 to the 15th atoms of calcium? It looks like we've had this problem before, but we haven't. So we've got our given, the number of atoms of calcium. That goes in our first box, 2.01 times 10 to the 15th atoms of calcium. And what units and what chemical go down and below to cancel? KV. It'd be atoms of calcium. What units and what chemical go above? Who haven't I picked on yet? Claire. Moles of calcium. Because we have to go through moles. So now, in that last space, Rachel, what units and chemical are going to go on the bottom there to cancel? Moles of calcium. What units and what chemical are going to go above? Skylar. What units and chemical are going to go in this last space on the top? Grams of calcium. Right. Now, if you look at this, hey, atoms cancel, moles of calcium cancel, I'm left in grams, that's what I want. These problems will solve themselves. You can check all your units. The trick, none of you are going to screw up putting your units in the wrong place, because you're going to check that. You're going to go, okay, moles, moles, atoms, atoms, it cancels, I'm good. The challenge and where you can screw these up is putting the wrong numbers in. That's why I really, really stress what goes where. So in that first box, go ahead and write down for yourself what you think goes top and bottom. Okay, you got the same raw answer as me. 13.37774826 times 10 to the negative 8th. Yes, ma'am. We have 3 sig figs, so we're going to be keeping this, rounding based on that. So it's going to be 1.34, and if we visualize that number to the negative 7, yeah. And the units are grams, and the chemical is calcium. Okay. Do you want to do one more two-stepper together, and then I'll turn you loose to work on the practice? Okay. So I'm going to hand you a sample, and I'm going to tell you that there are 9.95 times 10 to the 25th atoms of, oh, well, that's just silly, iron. Okay. I want to know what's the mass of this in grams. So if I hand you a chunk of 9.95 times 10 to the 25th atoms of iron, can you put this in your backpack? Do you need a pickup truck? Do you need a dump truck? Do you need a semi? How much does this, how much iron are we talking about? Okay, what's our first step? Given in the first box. 9.95 times 10 to the 25th atoms of iron. Okay, second box, down and below to cancel, units and chemical. What'd you say? What's the units and chemical down there to cancel? Atoms of iron. Okay, units and chemical on the top. Moles of iron. And on the bottom, in the last box, what do we have? Moles of iron. And in the top box, what do we have? Grams of iron. Okay, let's get our numbers in there. Jake, in that middle box, give me the numbers, top and bottom.
1 should be on the top, and then 6.062 times 10 to the 23rd should be on the bottom.
Yep. And in the last box, what are my numbers? You want to try it? Excellent. In 1 mole, right. And you're getting that number from the molar mass. Okay, now it's just math. Okay, so we fix it up. We get 9.23 times 10 to the 3rd. And what are our units here? Grams of iron. So this is 9,000 grams of iron. You can probably put it in your backpack. 1,000-gram piece of iron will fit in the palm of your hand. You got 9 of those. Your backpack's going to be heavy, but you don't need a truck or anything. Okay. You ready to do some work on your own? Okay, I will float and help where I can. We'll have a FIP on Monday.